1994, Colonel John Cavanaugh took command of the brigade, along with Command Sergeant Major Sandra Robinson. The brigade replaced the sole automatic multimedia exchange system to the new AutoDean Gateway message system.
Because there were 3 battalions that opened up that particular year, and because of my experience in Korea, I was selected to be the battalion commander for the 307 Signal Battalion. The benefit with the 307 Signal Battalion vice the 304th is when I was with the 304th, we were spread out over 3 different installations. And so command and control, especially in garrison locations, was a little bit more difficult than when I went down to the 307th. 307th was all on one installation, and during that period of time we were very, very successful in accomplishing a number of things. I'm proud to say that during that particular time we went from a straight ITSB to an ITSB with 2 separate companies. So the 229th Satellite Company was moved from Camp Humphreys down to Wagwan and was put under the 307 Signal Battalion. And we also stood up the 226 Signal Company Tropo at that time. So in an era of when they had declining resources from 1995 to 1997, I had the sheer privilege of growing the battalion by 50% from 4 companies to 6 companies. During the time when I was battalion commander with the 307 Signal Battalion, I had a very, very good friend that was the battalion commander for the 36 Signal Battalion. It was an era when we were really exploring putting in the seamless communications between the tactical and the strategic communications. Because we were friends and we had a very close working relationship, I would like to think that we were pioneers in being able to develop that seamless communications from the tactical line all the way through to the network. Terry Fong was a very good partner in making all of that happen.
Under the leadership of Colonel Richard Lee and Command Sergeant Major Charles Johnson, the installation of Switch Multiplex Unit SMU switched the Streamline Tactical to Defense Switch Network DSN.
About 1996, the OC3 microwave backbone on the mountaintop sites started arriving and started being installed. So that actually gave you a redundant path capability. And the advantage of going to an ATM-based architecture is on ATM, it would automatically switch to whichever path was open based on priorities if you had a cut on the FOXIC, which happened on a regular basis. If you look, about 1994 was about the year the World Wide Web came into existence. About the same time I arrived, and we actually had an early connection to the World Wide Web through a Unix workstation we had. But recognizing the demand both on email and World Wide Web was growing by leaps and bounds, the challenge was how do you get that to the last mile, if you will, to the end user? Because Korea had very old analog phone lines going out to little buildings, and a lot of times you'd have a Quonset hut, small metal building, with only 2 or 3 phone lines into the entire building.
Really, you were relying on copper wire telephone lines, and you're trying to, now, by the end of the 90s, of course, everybody's got computers, and you're trying to connect computers to these old copper wire lines. Well, the signal isn't good enough to pass the data.
So technology we looked at was the ADSL technology.
So ADSL really provided us a great way to have one phone line. You could also have your phone and your computer system. We could set up a network, and everybody could get pretty good connectivity, much better than what they had before.
Asynchronous digital subscriber line technology, which allowed you to share the same copper wires between a phone line and a digital connection. Because previous technologies required two pairs of digital four wires of straight dedicated connectivity. And the ADSL allowed you to share a phone line and a digital connection on one pair of wires that would provide data connectivity down to the end user. So we started the process and got the brigade to fund to put in shelves in tech controls where you would install shelves of this ADSL equipment, and then we would get users to buy the terminating modem and the modem to populate out these shelves, and provide these digital connectivities down to the building so they could have their email connectivity, their worldwide web connectivity, etc., down to very small locations such as Quonset huts and everything else.
In a lot of our posts, and you talked about the remote sites a little bit, on the mountaintops, but a lot of our sites that we provided support to were actually wired with old Japanese cable from World War II. So one of the big things that we supported during wartime was the 2nd ROK Army headquarters outside of Daegu, and they would go into this bunker area, but all the cabling inside was old Japanese paper-wrapped cabling, and we're trying to do VTC over this and hook up computer networks, and it just doesn't work. Putting the fiber optic backbone in was the first part. Then, of course, you had to extend out that good connectivity all the way out to what they call the last mile.
About 1996, the OC3 microwave backbone on the mountaintop sites started arriving and started being installed. So that actually gave you a redundant path capability. And the advantage of going to an ATM-based architecture is on ATM, it would automatically switch to whichever path was open based on priorities if you had a cut on the FOXIC, which happened on a regular basis. This happened to me several times. The fiber optic cable system, as I said, in 1994 was single-threaded. You went all the way from Camp Red Cloud all the way down to Pusan on essentially one set of fibers. There was one section where it was supposed to be dual routed, but the alternate route was unreliable. But other than that, it was single threaded all the way down, and I can remember specifically a UFL where a critical video teleconference was taking place, and about 20 minutes before the VTC was supposed to start, a Korean backhoe cut the cable.
The early 90s was the fiber ran parallel to the main highway that ran north to south. So whenever there was construction on the highway, which was all the time, the cable was cut all the time. I watched how the Korean nationals would set up a tent and painstakingly go through each individual strand of fiber to repair that across the board.
And the VTC did not take place and disrupted a major exercise with millions and millions of dollars being spent on it.
It just became a horrific nightmare because everybody depended on the fiber optic system because of its speed. Now, we did have an effective backbone system with the microwave and other communication systems on the peninsula, but the fiber was dependent on so much because we were starting to move fast into the digital and the computer technology in the early 90s.
By going to the ATM architecture with the OC3 backbone, had that same thing happened a few months later, it would have automatically, that would have been tagged as a high priority circuit, that automatically would have alt routed over to the microwave, and the users never would have even known that the fiber cut had in fact occurred. So it gave you redundancy and automatic failover capability.